Hello, welcome to the online portion of Alpha Educator's prep course. This is lesson 1 where we'll be discussing fractions, ratios, and percentages. A lot of this is probably already familiar to you. I just want to make sure everyone's on the same page when you enter the first class this coming week. First thing I want to go over is the difference between multiples and factors. Now, a lot of you know this, or sometimes you get them mixed up. It's pretty common too. Best way to remember it is that in order to get multiples of a number, you have to multiply it by some integer. For example, the multiples in 20 include 20, 20 times 1, 40, 40 times 2, 60, 20 times 3, so on and so forth. On the other hand, the factors in 20 are numbers that actually go into 20 evenly. These would be numbers like 1, 2, 4, 5, 10, and 20. Multiples and factors are very important. They play a huge role when adding fractions as well as when trying to find remainders. These are things, again, you've seen before, but I just want to make sure everyone's on the right page. When you're adding and subtracting fractions, don't forget to find the least common denominator. What that means is that if you have 1/4 plus 1/5, you have to find the least common multiple of 4 and 5 before you can add them. We're going to do some examples in future videos to help you reaffirm this and remember exactly what it means to do so. Multiplying and dividing fractions are a little bit more straightforward. With multiplication, all you do is multiply straight across. So you can multiply your numerator of one fraction by your numerator of your other fraction. And division, what you're going to have to do is actually flip the fraction. So if you remember, when dividing fractions, it's the same thing as multiplying by the reciprocal. And the reciprocal just means you flip the fraction. They're very important not only in multiplying and dividing fractions, but also when you talk about slope and different graphical issues that we'll discuss as we move on. Contracting fractions and ratios, it's very important to remember that these two things are different and what exactly the difference is between them, because this can help you solve some ratios problems as you move forward. Recall that fractions represent a part over a whole. So some examples that I've listed here are red marbles out of the total marbles, boys out of the total number of students in a class, or cats out of animals at a shelter. This is very different than ratios, which represent a part to a part, sometimes multiple parts of one thing. For example, we have red marbles to blue marbles, boys to girls, cats to dogs. Notice how these are kind of subgroups within the total cohort. In a class, you have boys and you have girls, so boys to girls would be a part to a part, whereas boys out of the total number of students would be a part out of the whole. When dealing with ratios, it's sometimes most beneficial to think of ratios as fractions instead of ratios. And there's a very simple method for doing this. What you have to do is just add all the parts of your ratios. So the example that I've listed here is, let's say you're dealing with a bag of marbles, a very common SAT problem. And you have a ratio of red to blue to green is 3 to 2 to 8. So the way that you convert this into a fraction, which might be more usable to you, is simply by adding those numbers. So 3 plus 2 plus 8 would give you 13. Once you know that you have 13, that's actually going to be the denominator in your fraction as you move forward. So instead of saying we have 3 red for every 2 blue for every 8 green, we can simply say that 3/13 of our marbles are red, 2/13 of the marbles are blue, and 8/13 of the marbles are green. This is very beneficial when they tell you maybe you have 250 marbles and you need to figure out how many are green. It's much easier to do 8/13 of the total number rather than trying to reason through what you have to get that to work. Percentages. So just very quickly, most of you again probably know this. Percent means out of 100. It can be set up as a ratio where you set your part over your whole equal to x over 100. You can cross multiply these terms, and that will usually allow you to find your percentage. Again, more examples to come. The next two formulas are extremely important. I can't tell you in the amount of time that I've been doing SAT prep How often I see students not use this formula or misinterpret what it means to do a percent increase or a percent decrease. I want you to memorize these formulas. In fact, I want you to have them memorized before class starts because we're going to be using these a lot since this is probably the most common place students get mixed up. Finally is the compound interest formula. Not necessarily something you need to memorize to do well in the SAT, but it would certainly be beneficial to you if you were to. It'll allow you to pick things out more quickly. Something else that we're going to discuss in the class is this translation method. I want you to memorize all of these. For most of you, you're going to find this actually pretty familiar. Sum, add, combine, these all are words that mean use the add sign. Difference or subtract, minus sign. Product or of. Now, of is one people commonly misinterpret. Of actually means multiplication. So if you see 3/5 of 100, that means 3/5 times 100. Quotient and per both mean division. Percent means divide by 100. What or a number or some number or a variable or it's kind of anything that sounds like that just means represent it with a variable. So that x in that case is the variable x. It is not the operator x. You can also use n, p, q, whatever works for you. What percent is actually just a combination of the two before. What means the variable x and percent means divide by 100. And then, of course, is or equals means the equal sign. So most of you, again, probably know this. I just want to make sure everyone's on the same page. General strategies. You want to think of ratios as fractions. That's generally going to benefit you in the long run. Anytime you see a ratio, instead of saying I got 3 blue marbles for every 2 red marbles, think 3/5 of my marbles are red and 2/5 of my marbles are blue. You'll find it's much easier to multiply out the fraction than it is to try to say, okay, well, if I have 60 marbles, what numbers are going to work out to give me a 3-to-2 ratio? Multiply the denominators of fractions together to get a smart number. I'm going to show you some specific examples of this in the future, but essentially what this is going to allow you to do is never have to deal with a fraction again. If you, let's say you have 1/5, 1/3, and 1/2. If you multiply the denominators, the 5, the 3, and the 2, that would give you 30. And with that 30, you kind of reason through the problem. Again, this is something that you're really going to want to see done in a problem before it'll make sense. And finally, make sure you use the percent increase or decrease formulas when needed. This is, again, probably the most common error I see students make when it comes to percentages is just trying to set up a percent increase or decrease without the formulas. A lot of times they're going to mess it up. Even the brightest of students will have difficulties with that. And that concludes the PowerPoint presentation for Lesson 1. In the future videos, I'm going to go over some more specific examples. So I know that was very quick. I know I ran through that pretty fast, but it's a video, it's online, you can watch as many times as you need. Make sure you get everything from that. There is going to be a worksheet for you to fill out that accompanies that video. So I will be sending that out to the class. Thank you.